Hello and welcome back again to the course Comprehensive Slope Stability Analysis using PLAXIS 2D. This is tutorial number 26, Consolidation Analysis of a Road Embankment on Soft Soil using PLAXIS 2D. So in this tutorial we will have a consolidation analysis for this embankment, which is 4-meter height and 16 meters wide. The slope of the embankment at both sides is 3 horizontal, 1 vertical, and below the embankment, the natural ground soil, we have 2 layers of a soft soil. One of them is a peat soil and another is a clay, and each of them is 3 meters in thickness. And below this soft soil we have a layer of 6 meters of a dense sand. So in this tutorial we will model this soil stratigraphy and this geometry of the embankment. So before starting modeling in PLAXIS 2D, let us shortly talk about the soft soil. And the soft soil is one of the weak and highly compressible soil, and that's most challenging in geotechnical engineering projects such as embankment and foundation. And this type of soils identified based on their mechanical properties rather than its type. So this type of soil generally has a very low shear strength, and because it is soft and cannot resist heavy loads, and also it is prone to failure. As I mentioned before, it is a highly compressible soil and undergo a very large deformation even when we apply a small amount of load. Usually classified, the soil is usually classified as a soft soil when its undrained shear strength is less than 25 kilopascal, or when significant deformation occurs under low stress. So this can be estimated usually in one-dimensional consolidation test or odometer test. And the important parameters of a soft soil model are listed in here. We have a permeability, vertical permeability, and horizontal permeability. This is very important parameter for a soft soil model because these two parameters control how fast water drains horizontally and vertically through the soil. Also, we have another two important parameters: modified compression index and modified swelling index. And these, as you can see, this is a relationship between logarithmic relationship between volumetric strain and mean stress. So from this relationship, this parameter can be found. Or instead of these two parameters, modified compression index and modified swelling index, we can use these two parameters, which are compression index and swelling index. These figures can be found from data of odometer test, and in PLAXIS there's two options. We can give or input the compression index and swelling index, so the software automatically calculate the other two parameters, which is modified swelling index and modified compression index. Also, like other soil constitutive models, we have a Poisson ratio for loading and reloading, effective cohesion, internal friction angle, dilatancy angle, and over consolidation ratio. Sometimes maybe we use these two parameters. Over consolidation ratio is a ratio of maximum past stress to current stress, and it shows if soil is normally or over consolidated. Also, we have a pre-overburden pressure or pre-consolidation stress. This is the highest or maximum effective stress that a soil has experienced in the past. So, as I mentioned before, we can also use, or if we have consolidation data, we can estimate these two indexes and used instead of modified swelling and modified compression index in PLAXIS 2D. So in here we can get the soft soil model and more detail about this type of soft soil model and all the equations and relationships from PLAXIS material manual, and I will upload this PDF under the tutorial, so you can download it and read all of them, and you will understand in depth what is this soft soil model and all important parameters. So right now let's open the PLAXIS. First I will copy the title of this tutorial and I will start opening the PLAXIS, and we start creating a new project, and I will paste a title in here. After that we click on the model, and I will assume that the original coordinate, which is 0, 0, is located at the middle of the natural ground. So I will need one borehole to create the soil stratigraphy, and I will model this embankment in structure mode using a soil polygon. So in here, as we can see, the X dimension for our geometry for soil stratigraphy is 120. So we will divide by 2. So in X minimum we will type minus 60 and X maximum positive 60. And for the Y in here we have a 10 meter. So for Y minimum we will type minus 10, and Y maximum you will type as a 4 because the height of the embankment is 4 meter. After that we click OK, and then we will start creating one borehole. So we click on here and we click on original point, and as you can see we have 3 layers, and we add one borehole. We assume the natural ground level elevation is 0, and we will type minus 3 for the peak layer. After that we will also have minus 3 to minus 6, and after that we will add one layer for the sandy soil, and also we have 6 meters, so this one will be minus 6 to minus 12, and we click OK. So as you can see we defined the soil stratigraphy for our model, and right now we can start defining the material properties for the embankment and all other soil layers.